So the top two paragraphs. And then we'll copy down our first theorem.
Oh, hello.
Are you recording this?
No, get right, dude. Okay, I'm going to go down just a little bit. Get that picture, make sure you get the picture. Then you guys can start copying down that box. The most important thing about today is you have to make sure you get those theorems copied down. I mean, see the bottom of that where it has that example down here? Those formulas are the most important thing today. You're going to have a lot of them. Lots. And guess what? You're going to need to memorize them to be able to do well in this section.
How many questions are we going to get?
I don't think we'll get to homework today is my prediction. When I taught this one to the honors class, I think it's just talking day. Talking and writing. Because it takes pretty much all out. I'll give you to the middle of maybe 5 minutes there to copy down all that. And then we'll talk about it. Which one? It's a line. So lines are always cursive. Good question. Make sure, like I said, that example at the bottom where it has those two formulas, get them written down. Okay, looks like we're winding down. Alright, first off, yesterday's thing was a tangent line. A tangent line intersects a circle at 1 point. Today is a secant. A secant is a line that intersects a circle at 2 points. Meaning it's a line that goes through a circle. Okay? So all these are J and K up here in our little picture are called secants. Okay. Any questions on what a secant is? So a tangent intersects at 1 point, a secant intersects at 2 points. First theorem. And today, like I said, we're going to learn a bunch of different formulas. Okay, they're going to get kind of confusing because a lot of them are very, very similar. So the first theorem says if two secants intersect inside of a circle, then we can find the measures of the arcs or the angles based on this formula. So the first formula says angle 1. Now this doesn't have to be in the center. These can cross clear up here, and the formulas stay the same. They can cross over here, down here, right there. They're rarely in the center. Okay, so you can't say this. Remember, central angles are the same, right? If this angle is 60 and it was in the center, this would be 60. These don't, this intersection, this angle is not in the center. So it's not going to be 60. So what it says is that angle 1 equals 1/2 times the arc that the angle makes. So angle 1 makes this arc plus the arc that's directly behind it. Or plus the arc opposite of it. So the angle equals 1/2 of the arc it makes plus the arc that's opposite of it. Angle 2 equals 1/2 of the arc it makes plus the arc that's directly behind it. So I wanted to show you an example of a problem before we go on. And I want you guys to copy this problem down here. So look at number, what is that, A? Right here. Copy down that circle. Come on. Why aren't you clearing? There we go. A little better. Okay, so this theorem says this. So, I'm going to help you write it down. So right here, everyone sees we're looking for angle x. So angle x, it's getting blurrier by the second, equals, so everyone write it down, angle x. So the way you write it down is just angle x equals 1/2 parenthesis the arc it makes. So as you guys can see here, angle x makes this arc. So 130 plus 84. So yep, you're going to have 1/2. So we'll see here if I can see it over here. Oh, good. They actually have a description here. Here, check it out right there. So that's the way you're going to write it. So everyone copy down the work right there too. So it's 1/2 times the arc it makes plus the arc that's opposite of it. So we know the measure of that angle right there, that example is going to be 107 degrees. I might even have you copy down the next one. I didn't even know these examples were in here. Maybe not. Maybe, but maybe not. Okay. All right, does anybody have any questions on that first theorem? Okay, so 1/2 times the arc it makes plus the arc that's directly behind it or opposite of it. All right, and it goes either way. Now remember, those two secants rarely cross in the middle. Rarely. I mean, I've seen them look as crazy as something like this. I've seen a problem on Alex before where it's that. So if it's like this angle equals 1/2 times that arc plus that arc. Does everyone see that? This angle would equal 1/2 times this arc plus that arc. Oh yeah. Well, it's all right. That's not important. Okay. All right. Sorry, I need to remember that. All right. Next theorem. Here we go. There you go. Right, if you want to even come post up over here by Maddie. You guys got another minute. Okay. Alright, now this theorem says that if a secant and a tangent line, so a secant line and a tangent line's on the bottom down here, secant line runs through it. If a secant and a tangent intersect at the point of tangency, I like to think of it like this. What kind of angles are these? What's the name of that kind of angle? These kind of angles. Does anyone know what these angles are called? We learned on this chapter. No, they are an acute and an obtuse one, but what are they called? They're inscribed. Now, the theorem also tells you that they're inscribed. The formula is over there. Now, how do I know that they're inscribed angles?
The corner of the thing on the edge.
The vertex is on the edge of the circle. Even though the other side of this angle doesn't come back into the circle, these are still inscribed angles. So angle 2 is 1/2 of that arc. It's just they're inscribed angles. Angle 1 is 1/2 of this arc. So if a secant line and a tangent line meet at the point of tangency, they make inscribed angles. And we know that inscribed angles are 1/2 the arc. Here we go. I want you to copy down this example inside your journal so you have one. Right, come on now. Right there, top one. Oh, that'll work. Yeah, that's nice. Just the top one, not B. Big box coming next. Okay, this is extremely easy. What it asks for is it asks for angle QPR, right there, the red one, right? Well, we know that the angle, because this is an inscribed angle, is 1/2 of the arc. So all we have to do is just go 1/2 times 148, or we know that the measure of angle QPR is going to be 74 degrees. So we can easily find the measure of this angle, right? So if this arc's 148, we can subtract it by 360 to figure out this arc. And then this angle would just be 1/2 of that arc. Easy, right? They're inscribed angles. Inscribed angles are 1/2 of the arc. The way we know that they're an inscribed angle is the vertex of the angle is on the edge of the circle. Okay, here we go. Next one, this one's a big one. I can't remember. Yeah, I can look there. One more big box after this one. I'll do a couple of examples after this one, just like I've been doing. Is it blurry? I think my contact, I think it's time to get a new pair of contacts out of my box. Yeah. Yeah, my left eye's clear, my right eye's blurry. Remember, pictures and examples down there at the very bottom are very, very, very important here. I'll see if I can get down so you can see that better. There you go. What do you guys need, about another 2 or 3 minutes?
Yeah, I really cannot see.
Scoot right over there. There's 2 empty chairs right in front of the screen.
Wait, is the left one and the middle one, are they the same formula again?
They're very, very similar.
Oh, DC.
This is a two secants, this is a secant and a tangent, this is 2 tangents. So they're different lines. You good?
No.
Okay. I'm going to start talking about 30 seconds probably. Okay. Now, when I tell you to write down the pictures and write down the formulas, there's a reason. It's because hopefully when you guys get the homework, when you get the test, you can go back through and you can see the pictures, right? And you say, oh, this picture looks like this one. Oh, this picture has two secants. Oh, this picture has a secant and tangent. Oh, this picture has two tangents. And you can go back and you can be able to see the formulas that correspond to the pictures. Now, these formulas are all extremely similar, but they're different because of the different types of lines. If you have two secants, so this is if two lines intersect on the outside of a circle. If two lines intersect on the outside of the circle, then these are the formulas you'd use. The one before if the two lines intersect on the inside of the circle. This is if the two lines intersect on the outside of the circle. So the first one, two secants. If two secants intersect on the outside of the circle, we can find the measure of this angle out here by going 1/2 times the arc that's farthest from it, subtracted the arc that's closest to it. The exact same thing happens here. We can find the measure of if this is a tangent and a secant. If a tangent and a secant intersect on the outside of the circle, we can find the measure of angle A by going 1/2 times the arc that's farthest from it, subtracted the arc that's closest to it. Once again, if two tangents intersect on the outside of the circle, so we actually saw this picture yesterday. Can someone raise their hand and tell me what we learned yesterday? What do we know is the same on this picture? Preston?
Line BA and C.
Yeah, those are the exact same. AB to AC is the exact same. That's what we learned yesterday, right? But today we're talking about the angles and the arcs. So good, Preston. We know that angle A equals 1/2 the arc that's farthest from it, subtracted the arc that's closest to it. So all these three are very similar. Basically, it's the angle equals 1/2 times the arc that's farthest from it, subtracted the arc that's closest to it. Any questions on any of those? Okay, let's copy down a couple examples inside of our book here. Okay, what do I want? Hey, copy down A and B. There you go. Copy down A and B. Tomorrow we'll do a bunch of math on this and then I'll assign you your homework. Anybody seen Lisa or Bella today? Okay. touching it. In. They may say that a boy or man can see us. With him I don't have to be shy. Right, Trent? Oh, with the bride in the first and the outer. Inner the last and then end. All right, everyone got those two examples down? I'll talk about the top one when you guys finish here. So the top one says angle L, right? Angle L equals 1/2 of the arc that's farthest from it, subtract the arc that's closest to it. So what are we after in here? We're after angle L. They tell us that this little section right here is 102. How did they know that this is 258? What are you subtracting from 102? Yeah, if it's two tangent lines, those things intersect at one point. So if this is 102, 360 minus 102 will give you that one. Oh, they showed you right here. Okay? So we can just go the arc that's farthest from it, subtract the arc that's closest to it, and get our solution. This one right here, though, this one's asking for the arc, and it gives you the angle. So it's the exact same formula. The angle, which is 56 degrees, equals 1/2 of the arc that's farthest from it, subtracted the arc that's closest to it. And you just solve it that way. Hey, what did they do right here? Can someone tell me what did they do to get from this step to this one? Good. What? Why? Why did they times? So they had to get rid of the way you get rid of a 1/2 is you have to times both sides by 2. That's how you get rid of a 1/2. So if they're asking for an angle here, hopefully everyone wrote down these steps.
That's 207 or 217?
207. Okay. Any questions on any of those? Like I said, tomorrow we'll do all kinds. Okay. Last box, and this puts it all together.
Wait, hold on. Let me look at this again.
I don't know if we have time. What do we have left?
Take a picture on your
Yeah,
phone.
here. Yeah, we're gonna have to go. We got a copy. Okay. Look, I added my own little writing to this a little bit. So this puts it. Now look, this thing right here says vertex of an angle. I want this whole thing copied out just like it is. Vertex of an angle. This is if the vertex is on the circle. This is if the vertex is in the circle. This is if the vertex is outside of the circle. Okay. I want those things copied down. So this is if the vertex is on the circle, in the circle, and outside the circle. So these are all, you've already written down all these inside of your journal, but this brings them all together in one chart, kind of.
Are we gonna be running more after this?
This is it. We don't have enough time. Man, I drilled that, didn't I? I said, we're probably not gonna get to any homework today, so maybe. We'll play it by ear. You guys got about, what do you need, 4 more minutes maybe? Yep. Okay, you guys got about another minute. Yeah. I'm gonna see if I can't get in just a touch here and see if I can't make it a little bit. Okay, so these last 3 boxes right here, fresh and have a seat, talk about the measure, talk about width, what kind of formula you're going to use, if the vertex of the angle is in certain areas. Whether it's on the circle, in the circle, or outside the circle. As you guys can see here, this is the vertex of the angles. If they're outside, you notice here, we're just gonna have like a subtraction. Right? Inside, you're gonna have an addition. On the circle, it's 1/2 times the angle. We know if an angle is ever on the circle, it's an inscribed angle, so it's 1/2 the arc. If the angle is inside the circle, it's 1/2 times the arc it makes, plus the arc that's directly behind it. And if it's outside the circle, it's going to be 1/2 times the arc that's farthest from it, subtracted the arc that's closest to it. So, listen, I know how much material that was in one lump sum. Don't get me wrong. I mean, I am fully aware how much material that was in one day. Okay? I mean, anytime you spend an hour writing only in journals, I understand how much it is. Tomorrow, I'm probably gonna teach for. I mean, it won't take me much long to teach, because you're gonna have some examples down. I'll go over a few more examples, probably like 15, 20 minutes, and then we will send you off on your homework. Does that sound good with everyone else?